Okay, here's our 6.4 transforming linear functions. You are going to see everything about transformations all throughout Algebra 1 and Algebra 2 and geometry. So you're going to see this lesson probably like 10 or 12 times before you leave high school, and it is very important. So try to get as much of it as you can now so that that's going to make your future lessons easier. Also, today I'm going to have you do a lot of pausing to think before you figure out what we're supposed to be learning today. So the first thing I want you to do is pause the video and write for me what are the 3 different forms. So write the 3 different forms and make sure you know what all of the letters in each form mean. So pause and do that now. Here are the 3 forms. So in slope-intercept form, remember M is my slope, B is my y-intercept. If you don't remember that, you probably need to add that to your notes. In point-slope form, M is still my slope, and X and Y are a point on my line, a point that they give me. Remember that because they're inside parentheses, they're going to be opposite, so we want to make sure we think opposite for those problems. And then standard form, X and Y are on the same side of the equation, and then A, B, and C are all integers or whole numbers. Nothing should be a fraction. Okay, one thing we need to take a note of before we look at a few of the different transformations is something called a parent function. A parent function is just the most basic form of something. So it's the most basic form of, today we're talking about transformations of linear, so it's the most basic line. And the most basic line, so we think y equals mx plus b, is one that starts in the middle. So it starts at the origin, and the slope is going to be 1 over 1. So I'm going to rise 1, run 1, rise 1, run 1. I can go the other direction. I can go down 1 and backwards 1. Do that again. This right here is the parent linear function. Parent linear function. And if we write that out as a formula, so I can say my slope is 1 over 1, my y-intercept is 0. This plus 0 I don't really have to write because adding 0 doesn't change anything. And 1 over 1 is just the same thing as 1, or just the same thing as x, since it's 1x. So this parent function is y equals x. So just keep that in mind. Okay, so the first transformation we're going to talk about are translations. What you see here is an example of translations. Remember, this blue is your parent function, and you can see it here on the graph. You've got your parent function there. I want you to just pause the video and look at what is the green equation doing. So this equation, how is it changing what the graph looks like? All right, I'm going to ask you to consider the same thing for the purple equation. What is happening in the equation that's changing the graph? So pause and see if you can figure that out for a minute. All right, and hopefully what you noticed, the plus 2, if we think about our y-intercept here, the plus 2 took the entire line, every single point on the line, and it shifted it up 2. So that's how we got our new line. So for translations, if you add a value, you're going to move up. And then on the purple equation, you should have kind of figured out something very similar. On that one, it says minus 3. So if you're subtracting, that's going to make you move down. So see, the minus 3, we had to move down 3 to find our new points from the parent function. All right, so then consider if you had y equals x minus 8, think about what do you think that would do? And hopefully you get that this should move your line down 8. Okay, here's our second translation. Again, our parent function is in blue. So blue is our parent. In your notes, you can be writing down these equations and just taking note of what's happening every time. So I want you to think about what is happening in this equation and how is the green line looking different from the blue line. So that's what you're comparing everything to. Always compare to your parent function line. So think about what is different or what's changing. Do the same thing for your purple line. Consider how is the purple different from the blue? What's happening every time? So pause and take a minute to think about that. Okay, so hopefully what you noticed is that they still have the same y-intercept, so the line itself is not shifting up or down, right? The line is staying in the same spot, but instead the line is being stretched or it's getting steeper. So they're all starting from this origin point, but on the blue, my slope was 1/1, and on my green, my slope is 2/1. So if you think about what that means for the graph, the things that maybe you want to make a note of is that the slope is going to change and it's going to get steeper. So 2x causes you to have a steeper slope. And then if you look at the purple line, 6x has an even steeper slope. So even steeper. So what you should maybe think about then is if I told you maybe something with a slope of 8x, would that be even more steep or not as steep? And you should notice that it's going to be even more steep. So just know the bigger the number, the steeper the slope. So that's what I'm going to put. That's the last little bullet point I'm going to write down, is that the bigger the number. And when I say the number, I'm talking about the number that's multiplying by x. So the bigger the number multiplying x, the steeper the line. Okay, now let's consider compression. So same idea. I want you to compare this equation with how it's changing the green line, this equation with how it's changing the purple line. All right, notice you're not shifting anywhere. So we didn't move the green line up or down. All we did was change the slope. So now the slope is 1/2. So instead of being steeper, notice this green line is getting even more flat. Like if you think about that being a hill, the green line is easier to walk up than the blue line. So it's getting less steep. We call that a compression. So notice these are not whole numbers anymore, they're fractions. So the thing that you may want to make a note of is that fractions make lines and slopes, so I'm going to say make lines/slopes less steep. That's why we call it a compression, steep. That's why we call it a compression, because you're kind of squishing the line down. So think about it like squishing instead of stretching to make it larger. So, and when you do 1/6, it's going to get even smaller because 1/6 is a smaller fraction than 1/2, right? You're choosing less pieces if you want to think about fractions as pizza, okay? Reflection. So take a second to compare the two equations that they give you. So compare the difference between the equations and then how that makes the line different. And what you should notice is that there's a negative sign here. So because there's a negative, we're going to say that that reflects or flips. So negative times the x. So, and I'm saying that because that's really like -1 times x. There's a negative times the x gives a reflection. And what we mean by that is this line is literally being flipped. So think about it like if you were to fold this graph in half, right? If you were to fold across this purple dashed line that I'm making here in the middle, it would become this green line. That's what's happening. So reflections happen when you have negative being multiplied. Okay, so here are your lesson check questions. This lesson was pretty short and relatively easy. Really, you just need to be able to answer these 3 things before you come in tomorrow so that we can talk about and work some problems together in your lesson before we do your practice test.